All right. So without further ado, tonight's presenter is going to be Brian Schwind, whom you might remember if you're an old timer. If you have seen Brian's first presentation talking about the keyboard that he built, please raise your hand. One person, two people, 3, 4. Okay, this is cool. It's going to be new for most people. If you have not seen his presentation, feel free to watch it on our YouTube channel. It has the most views by far. 65,000 people have seen it. Yeah.
Please clap.
Okay, so I thought that Brian needed no introduction, but I realized he does. So he's a software engineer at Tonari. He has a very deep interest in actually building physical things, electronics, mechanical stuff, and he's a really good friend of mine. I used to hang out with him all the time until he moved to Okinawa, so now I'm sad. And in the first installment of his talk, he talked about a keyboard that he built from the ground up, designing the PCB and everything, every piece of electronics on it. And then he wrote the firmware for it in Rust, which was quite an interesting undertaking. And he left us on a little bit of a cliffhanger. He said he would talk about how he built the other physical parts of the keyboard. So now he's going to deliver on his promise and do exactly that. Please give him a very warm welcome.
Thank you, Mate. Wow. So yeah, the talk is building real stuff in keyboard cases too with Rust. And yeah, Mate already went over this. My name's Brian Schwind. I've been working with Rust since 2015. My friend Phil, who's actually in the audience, was the one who introduced me to it. And I've been working with it professionally since around 2018 or so. So yeah, again, about 1.5 years ago, I gave this talk about building this keyboard and building the firmware for it in Rust. And I left us on a cliffhanger of, what's next? This keyboard needs a case too. So now this talk is going to be about that. So show of hands, who here has designed a part and 3D printed it or machined it or produced it in some way? Okay, that's it's like 80, 90% of the crowd. Who did it with just code? 2 people? All right. Who wants to 3D print stuff and design things, but maybe doesn't know where to start or feels intimidated by the tools that are out there? Or not intimidated? Okay, who wants to build stuff with code? Hopefully someone. All right, cool, good. I got you all to raise your hands. So I'm going to go over the tools that are out there for when you want to design and make something. Code-based CAD in particular, its benefits and drawbacks and why you should try it. Writing Rust bindings to a C++ CAD kernel is something that I did to build this keyboard case, weirdly. And the future of code-based CAD and what I think some things that are going to come out that can maybe make things even better. So in my last talk, I had a disclaimer that I'm not an electrical engineer, and I was talking about making PCBs and that sort of thing. This time, I'm not a mechanical engineer. I'm still just a software engineer. So yeah, I work with software. So this is coming from a software perspective of I know how to write code, and I have a 3D printer. I want to make stuff, but I'm not making things that people's lives depend on or anything like that. So if there's any mechanical engineers in the crowd, feel free to call me out. Yeah? Okay. Keep me in line. So I'm going to go over just some basic terminology, and again, correct me if anything is off. Just because I'm going to mention this later on for various tools. So fillets is a big thing that I'm going to focus on, and this is just sort of smoothing out connecting edges to give it more mechanical strength. So this is a very common thing that you want to do to models when you're designing things. Chamfers as well. It's sort of like a fillet, but it's like a squared off edge, essentially. Oftentimes 2D sketches are involved, so you'll make a 2D profile sketch of a part and then extrude it at some point. So people designing parts often work with these 2D sketches. You have work planes that you put these sketches on. They don't necessarily have to be at the 0 point of the origin. They don't have to be just these planes, but any plane that you want to work on, you kind of give yourself a 2D surface that you can draw this sketch on and do something with. So extruding, again, drawing a 2D profile and just extruding it along some direction, and you get a solid part out of it. Lofting is something else that you can do. So you start with like shape A, shape B, and shape C, and you say, sort of, give me this solid that sort of blends between those three profiles. So it tries to make sure that the curves all kind of go through each of those shapes, and they can, you can start with a square and end with a circle, and it sort of smoothly blends in between those two. Revolving, you sort of give a profile that gets sort of revolved around a particular axis. So for things that are like radially symmetric, it's very easy to model parts like that. It's like a wine glass or a torus donut. Yeah, so we have, from the last talk, we have the PCB, the keyboard here. This is just the PCB itself, and then a top plate, and we need to make a case for it. So I usually start by just drawing stuff out on paper. And even before I wanted to make the 3D printed version, I just made sort of a 3-layer, like, stacked up version. It looks like this. And that one's good for working on a desktop or somewhere where it's just propped up. It looks kind of cool. It's very easy to construct. You don't really need a case around it. That part's nice. But I also use my MacBook a lot when it's not dead. And it's nice to be able to actually, like, I really enjoy using this keyboard. I've been using it for like 2 years now, and I miss it when I don't have it. So I wanted to be able to place it on top of my MacBook as well and use that. So when I get that fixed, maybe I can use it again. So again, starting with paper, I just sort of sketch out like roughly what I want to design. And like at this point, a normal person would pick up like Fusion 360 or SolidWorks or Onshape. There's all these professional tools out there that if you're a mechanical engineer, you're probably using, that you're just a wizard with, and you could crank out this part in 10 minutes or something. I didn't reach for these, partly because I'm cheap and all of these cost money. They're also not necessarily open source, and it's sort of something that you rent, and it doesn't feel like you really own the things that you've designed over time. And I want to have that feeling of just like owning the entire process from start to finish. And none of these are open source as well. So you think about like, okay, like maybe Blender, like Blender's an open source thing. You can make 3D stuff in it. I briefly tried using it for CAD, and it was just a nightmare. If you want like accurate, like millimeter dimensions and that sort of thing, Blender's not quite the tool for you. It's more geared towards 3D modeling for film and that sort of thing, making like organic shapes and characters and stuff like this, less so for like mechanical parts. So there's some plugins that you can use with Blender that make it slightly easier. Two that I know of are CAD Sketcher and Blender Precision. I tried these out, but I still felt like something was a bit off. Like you have the whole rest of Blender just in there, like it's kind of unnecessary. And it makes it feel very complicated to go in and just change stuff. So there's also FreeCAD. And I would describe FreeCAD as the GIMP of open source CAD tools. So if you've used GIMP, you probably can imagine. It's overwhelming to me. I've tried to do some very simple stuff with it. I'm sure if I read some articles, I could figure it out. But I was immediately repelled by this and just did not want to use it. There's a fork of FreeCAD called Onsel or Onsel. I'm not sure how to say it. And their goal is to make a better UI for it. So that's a noble goal. So I should give that a try at some point. I didn't know about that when I started making this keyboard case. And there's another tool that I actually really love called SolveSpace. They have a great 2D sketching tool here. You can define constraints between things. You can say, like, I want this line segment to be parallel to this one. I want them to be equal in their dimensions. It's really quick to sketch something out. But the 3D aspect of it is a little bit harder to work with for me. And I still feel like with any of these tools, I'm sort of on this Jenga tower of things where, like, if I click something wrong, am I going to be able to, like, undo and go back? Like, I always felt slightly uneasy using all of these tools. So if you're a mechanical engineer or a character modeler or whatever, you have these tools and you're used to them. Like you open up Blender and you just crank out whatever. I open Blender like once a year or so, and every time I do, I have to go to like a bunch of references and figure out how to do the basic stuff. But I'm a programmer, so I can open up my text editor and terminal and all that, and I know, how to write code, of course. So with a tool that I use every day, I'd like to also be able to use that to create my own CAD models if I want. So in 2019, a friend of mine had this Android phone. It's like this e-ink Android phone. It actually, like, you can install whatever Android apps on it. It refreshes at like half a frame per second. And he was printing, he was 3D printing a case for it. And I was just like, wow, where did you, like, did someone make a case for that or what? And he was like, no, I designed it. And I was like, what did you use to use that? I was just kind of curious. And he said, I used OpenSCAD. So I had never heard of that before, or just heard it in passing, but he got me to actually check it out. So the basic idea with OpenSCAD is you have a code editor on the left and the 3D view on the right, and you just write code, and as you're writing it, it'll update, and you can see the results of what you wrote. So you just start with these basic shapes like cubes and cylinders and spheres, and you just subtract them out or you union them together, and you just combine them into these more complicated parts. So those set operations that I'm talking about is CSG, or constructive solid geometry. So to create this thing, you like union these cylinders together, and then you take that union part and you union it with another cylinder, and you get this thing. Over here, you intersect this cube and this sphere, and then you get that part, and you subtract it, so then you end up with this part that you're never actually going to use or print, but they always show this to demo CSG. So that's the basic idea behind OpenSCAD. But if you're used to a normal programming language, you're going to not like OpenSCAD's language very much. Variables don't quite behave how you'd expect. It's a bit strange. So despite that, people make some really impressive stuff in it for how painful the language can be. So like that's kind of cool to have all these cool curves going on. They've made these parametric keycaps, but at great cost to their sanity. So a lot of people end up using their favorite language to generate OpenSCAD. So there's, you can use a normal programming language, and honestly, like, this is a good stopping point for many people. If you just want to make a simple part or something like that, you can have like JavaScript sort of, or any language, generate OpenSCAD code and just keep your sanity for the most part. Matt Aderith gave a presentation really similar to this one. It was also about building keyboards. And he used Clojure to generate OpenSCAD code. So that's a good talk as well. So go check that out later. There's also some crates in Rust that I saw and tried out just a little bit to generate OpenSCAD code. And I even set up like Cargo Watch, so like I would edit the Rust code and it would compile to OpenSCAD code, and then the OpenSCAD viewer was running and it would see the SCAD code change and refresh and everything. It was a cool iteration cycle, but every time that I was using it, I just felt like something's kind of off. Like why is it making me like place all these parts here? It's not telling me any information about like what I placed. You end up having to do a lot of math on your own. OpenSCAD doesn't do much for you. So the reason for that, though, is just because it's based on triangles at its core, and that's just how the tool is. It used to use a kernel called Seagal, and they've recently switched to something else called Manifold, which is a much faster version of that. But still, everything is still triangle-based, and there's limitations to that. For example, like I make some part and there's an edge on it and I want to add a fillet to it or something. How do I do that easily? OpenSCAD doesn't have like a built-in thing where you can just quickly do that. And if you look at like any parts that are out there in the wild, just after this talk, hopefully you just go and notice these things everywhere. There's fillets and chamfers and like all kinds of nice like rounded off things that are very difficult to do in something like OpenSCAD. So lots of examples here. Even in the 1700s, we were chamfering boxes just fine. So I think I'd like to still be able to do that today. And if you want to add fillet or chamfer operations to OpenSCAD, you can earn yourself some money and get this bounty. So the alternative to having a triangle-based, or one of the alternatives to having a triangle-based CAD kernel engine is using something called boundary representation, or BREP. And it's what all the bigger packages typically use, like SolidWorks and other things. All of those packages are sort of powered by what's called a CAD kernel. It's like the underlying thing that crunches all the numbers on the geometry. And there's really not many of them in the world. They're pretty tough to make. So there's a few listed there. And boundary representation basically takes these mathematical representations of like an edge or a surface of some sort, and it bounds them, and it sort of defines the inner and outer boundaries of a part. And you typically build things up by creating vertices and connecting them together, connecting edges together to form a face, and then you connect these faces, and that forms a shell or a solid at that point. And then you have your boundary defined. And similarly, if you've ever tried to get something manufactured that typically asks for a step file, there's probably other formats out there as well that I'm not aware of, but I think step files are sort of the predominant way that you share CAD data with other tools or other like places if you want to get something manufactured. Sort of like an SVG to a PNG. Like the SVG has the original like math equations in it, and a step file is sort of the same. So you can always generate a triangulated mesh from a step file, same as you can generate a PNG or something like that from an SVG. If you want to add step format export to OpenSCAD, you can also complete that bounty and earn some money. So out of all the CAD kernels that I listed that do boundary representation, there's only one or two really that are open source at all that you can even just go out and use. And by far, I think the most popular one is OpenCascade. They have very similar names. There's another one called BRL CAD, like Ballistics Research Laboratory CAD, developed by the US military, I believe. I wasn't aware of that one at the time, and I just learned about it. What's that?
A guy named Lee Butler. I have lots of Lee Butler stories.
Yeah. Yeah, it started quite a while ago, both BRL CAD and OpenCascade. So it was sort of born out of this Euclid CAD system from 1980. They open sourced it in 1999, and it's what powers FreeCAD and many of the other open source CAD projects out there. It's also written in C++, and it's been like, you know, they've just brought it through the decades, updating it occasionally and using some modern stuff. So it's not like the crustiest C++ code base you've ever seen, but it's kind of bad in a way. Has a lot of baggage. It's 2.5 million lines of C++ and 12,000 lines of CMake. And how many people have interacted with CMake in some way? Yeah. Okay, so you hear 12,000 lines of CMake and you feel pain immediately. So that's like a pretty juicy target to rewrite in Rust, right? Yeah, like let's rewrite the whole CAD kernel in Rust. Maybe not. So CAD kernels take a long time to develop. That's why there's so few of them. So if I wanted to get this keyboard case done, I didn't want to spend like a decade on it and have like a half implementation of something that's already out there. So my strategy was OpenCascade exists and it's pretty good. It's written in C++, but let's go ahead and just create like a Rust API on top of it, something a bit nicer that we can use, because I don't like interacting with C++ directly most of the time. And if a Rust CAD kernel ever gets developed eventually, we can swap them out later. So that's the strategy. So Mate gave a talk a few months ago about binding to a finite element analysis package using CXXRS. So it gives you sort of a safe way to bind to C++ code. It's not that fun or easy, but it works. So my strategy was like, okay, let's just try to get OpenCascade to build at all in a build.rs program. Let's try to just get it linked to the correct libraries, and then we're just going to call a single OpenCascade function. Just create a vertex and see if we can get the data back from that vertex. And if that works, I'll be excited. So this was like the first program that I got after spending hours and hours just getting the bindings and everything like built and generated correctly. So it's really boring though. You just create a point and then you get the Y value and you just print it out. So I get this printed out. It's the dumbest thing ever, but I got really, really excited about that. It's sort of like when you work with a new graphics API and you get a single triangle drawn on the screen and you show someone else, and they're just like, that's what, cool, you drew a triangle on the screen. And you're like, dude, do you know what this means though? This means I can draw like the entire model. Like, do you get the, and they're still not excited, but same thing here. You can now bind to all the different OpenCascade functions and start like actually building stuff. So that was my goal, is to just keep doing that until I had something workable. One thing I really like about OpenCascade, they have a tutorial where you make an actual like useful thing instead of like a sphere with like some cylinders and cubes like jammed into it in some way. So they have, this is kind of a famous tutorial. It's just a bottle, but it's complicated enough that it's kind of a nice thing to try to recreate. It even has like threading on the top. So that was a little complicated thing that they threw in there. So my goal was to just recreate this bottle one-to-one in Rust code so that I could get familiar with the kernel and just see the process of binding to C++ and see if there was a way that I could automate the bindings for it later, but I haven't done the automated part yet. So I went to Izu and just like, I had an Airbnb and it was super cozy and rainy, and I just sat down for like 2 or 3 days and was just going through like making this bottle in Rust. And I ended up with essentially the same code. It looks exactly the same. It's horrible, horrible Rust code. So you wouldn't ever want to like write it like this, but it's basically one-to-one to the C++ code on the right there. And then once you have that though, then you can start making like higher level, abstractions around it. So this is the same, this was like 200 lines of code-ish, 220. This is the same thing except for the threads on the bottle, because that's still kind of hard. But it makes everything else on the bottle, and it's like, what, 40 lines of code or so? You can keep going, you can keep simplifying it as well. So you can, I think Rust can let you create a nice API on top of this. Like, you can do the same in C++ as well. I'm not saying you can't. I just want to work with Rust instead, as probably most of us do. The bindings, however, are not super enjoyable. There's some peculiarities with OpenCascade. So I haven't found a way yet to just like automatically bind to all these different functions without writing like a C++ parser or something, and I didn't want to go through that. So I've just been manually adding them, but I'd love to come up with a solution to make it more automatic than it is. And then I had enough useful stuff that I actually wanted to publish this on crates.io. I had OpenCascade as a submodule in the crate, so that's a lot of code. If it's from 1980 or so, they've accumulated a lot. And there's a 10 megabyte crate limit on crates.io, so I immediately blew that out. It was like, after compression, like 100-something megabytes. So you go through, cargo.toml lets you exclude a lot of stuff. So there's like test data and textures and like 3D stuff that I don't need because I'm going to use something in Rust instead. And this was sorted by the largest directories and files and all that. It went on for 400 or so lines of excluding, and I would like do cargo publish, dry run, see the size of it. I don't know if there's a faster way even to do it or not, but it was really painful. And then I eventually got down to exactly 10 megabytes and published it, and they accepted. I thought maybe they'd be like, oh, it's exactly 10, it needs to be like less than 10. No, it accepted it. And then I was terrified if OpenCascade ever updated again after that, because I was going to have to probably do the same thing again. And after I did all of that, I come across this comment from Alex Crichton from 2015, where he adds the ability to special case a crate on crates.io and give it more memory, or more space, rather, for each crate individually. You could just email this address and request it. So I did. And after 6 days, I doubled my crate size from 10 megabytes to 20. So we have a lot of headroom now to keep adding more and more code to it. And I deleted all the other exclude stuff that I didn't need because I was feeling really bad about like carrying that complexity around with me. So here's some examples of like just some random shapes and things. There's like an examples directory in my repository, and this is one of them. It's not that exciting, but I was excited because I love like things that are kind of polished off a little bit like this. It's sort of like the iPhone like 4 or 5. Like it's got that rounded edge on it, but it's also beveled on the sides and everything. So I wanted to recreate something like that. And this is the code for it. So you just start in a particular work plane. So you're starting in 2D, you create a rectangle, you fill it the entire rectangle, so it'll just round all the corners, convert it to a face, because it's technically a wire. And then you extrude that, and you have a solid. And then there's sort of like a query-ish language or something, DSL, I don't know, based on iterators in Rust that I've tried to make. I'm still experimenting with the code overall. But you can say, OK, give me all the faces on the shape. Give me the farthest one in the positive Z direction. So we've got like the top face. And then just give me all of the edges for that top face. So that returns an iterator over the edges. And then you can just pass that back in and say, OK, shape, here's the edges that I want you to chamfer. And then, yeah, so you end up with this part overall. This was like a mini PC thing. I wanted to like hook it onto some wire rack. So this is like some very weird specific model that I've created. This was a like flat Ethernet cable thing I wanted to run through my house. So like a thumbtack goes through the middle of that. This is like a really small part. And for some of these too, I brought some of the 3D printed parts if you want to see that later. Like a cable, a stronger cable holder with 2 thumbtack holes this time. But anyway, those are some of the things that I've made with it so far outside of the keyboard case. So there's some nice things about Rust overall that I enjoy with code-based CAD. Anything in Rust that returns like the result enum has the must-use attribute on it, so it'll like remind you if you just like call the function but just don't assign it to anything or don't bind it, it'll complain and be like, hey, did you mean to like not use this thing that you just created? So you can do the same thing on your own functions. So most of these shapes and their functions that I have on it will modify the shape and return a new one. Or sorry, it won't modify it. It'll create a new one and do your modifications. And if you don't assign it to something, it'll warn you about that. Iterators are also great in Rust. You kind of saw like selecting edges and faces and that sort of thing. There's some operations in CAD that can fail, like if you try to have a radius that's too large when you're trying to like fillet an edge, a result can tell you if that failed or not instead of, well, currently it seg faults, but in the future, it'll return a result. And then you can act on that or something. You'll probably still just panic anyway. You can have general type safety and like all the benefits that come with it. So like if you're on docs.rs or whatever, you look at a wire, or if you're in your IDE and you have a wire and you say wire dot something, you can kind of see all the different stuff that you can do with it. If you want, you can use strong types for things like radians versus degrees, so you don't get those confused. Millimeters, inches, all kinds of different units that get used in design. For functions that mutate apart, that's marked in Rust, so things are mutable or not, so you can kind of tell if something's going to get changed in some way, or if it like returns, if it consumes something and returns a new thing, you kind of know, like, yeah, it's clear when something gets modified or not. And it's not C++, so that's also nice, in my opinion. Yeah, and then like going on as well, this is sort of just general benefits of Rust. You don't have to re-implement everything or go through the pain of writing CMake files to get the libraries that you want to use. So like if there were a step file importer in Rust, you could probably just add that in. If you want a graphics API like WGPU or something, it's easy to pull that in. You don't need to like add all of this stuff to your project. Enums are good. There's other code-based CAD tools that use strings a lot for like defining different work planes or directions or like query languages. So it's nice to have stronger types there with enums. And on and on. Operator overloads are always nice when you're working with like vectors and that sort of stuff. And yeah, all the other sort of niceties that comes with Rust. And again, Rust has a great package manager, so it's easy to share parts. And if you want to add a package manager for OpenSCAD, you can also earn yourself a chunk of change and implement it yourself too. The not so nice parts about Rust, though, for something like this is compile time. So it's like, this is actually where a scripting language is pretty nice. So we're binding to C++, essentially, and we want to iterate. Like, you want to make a model, and you want to see like how it's going, essentially, and you want to like make a change, and you see visually, okay, it's like it did the right thing. For Rust, though, as it is right now, you have to go through that compile cycle, and it takes quite a while. And if you don't do things like dynamic linking, you end up with this giant static binary that just like prints out a cube or something, which is a bit overkill. Same thing with the borrowing system. Since we're like mostly talking to OpenCascade, they have their own concept of handles and memory management and that sort of stuff. And we're not really gaining a lot from Rust, like memory safety guarantees. And the performance gain like that you might get if you use Rust versus something else is sort of moot because you're just calling C++ code ultimately. So we're not getting those benefits from Rust, but again, there's other benefits besides those things. This was an interesting problem that I'm going to try to breeze through this a little bit, but when you're writing, this is just like generic any sort of Rust library, and you want to write something that accepts a collection of something, and maybe it's like a collection of references to that something. I like struggled a bit with how to represent this in a good way so that the call site doesn't have to like manipulate what they have in order to fit what the function is trying to accept. So like if you wanted to fillet the edges of a shape and you just pass in the edges here, like yeah, you could get by with a slice of edge references. But if you try to call this, and also just a side note, I have another function that returns an edge iterator called edges. That's going to come in handy later. If you try to just pass that in though, it's going to complain about like, oh, you tried to pass a vector in instead. I was expecting a slice. It's completely different. So you go through this whole thing. In order to get it to work, you'd have to like, if you wanted to pass like a slice of references, you end up like collecting it into this vec, and then you have to like build another vec of like containing references to those because these have to live long enough, and it just becomes a mess. And then like I'm just trying to call this thing. And you might come up with different ways to solve this in a nicer way, but I struggled a bit. And you come to like decide, okay, maybe like infiltrate is what I want to use. So like we'll implement anything that implements an iterator and gives us a reference to an edge. And you kind of still run into the same problem. So that edges function like returns an iterator of edges, but it's still just like, it's like, oh, you passed me an own value, but I was expecting a reference to that value. And it's sort of like the same, like you can always pretty much get a reference to that value if you have an own version of it. Correct me if I'm wrong, but I couldn't get the compiler to like accept this stuff in a nice way until I sort of settled on this pattern. So I've used this like everywhere in the code base. Again, come talk to me if you know a better solution to this problem, because this is what I settled on. So we have a T, which implements as ref edge, so something that can become a reference to an edge. And then I say the edges will be something that can iterate or something that can turn into an iterator of this T. And so what that looks like is you have to say edges.intoIter to convert whatever they passed in to be an iterator itself. And then we have to call edge.asRef because that's what this T is. And that actually works. And then you can start passing in, well, one little detail. You have to implement as ref something for the something that you want to pass in. So if you want to pass in an edge or a reference to an edge, you need this piece of code here. But once you have that, this function becomes like what it should be, which is self.fill at edges, and what edges do I want to pass in? It's just the iterator without having to collect it or do any intermediate work on that. Again, talk to me if you have a better way, because I might have just missed something entirely. And yeah, how are we doing for time here? Okay. So why do I like code-based CAD? Of course, it's just code, so it's very trivial to version control. You can compare versions super quick. If you want to experiment in some way, you just branch out, create something else, see how it looks. There's no worry about really like losing data or something getting corrupted or messed up. If all of us hopefully are programmers, not hopefully, but all of us in the room have worked with programming languages, I would assume. So if you've ever just used a library before, it's very easy to just pull another one in and generate a shape of some sort. One of the main benefits probably though is like if you're modeling something that has a lot of like arrays and like complicated stuff that would be a huge pain to like click around everywhere, you can use loops and control flow and that sort of thing to just quickly generate like some intricate pattern that would take hours and hours just doing manually. But with code, it's quite easy. Again, yeah, you can use your package manager in your programming language of choice to share part libraries. If you made like a set of like washers or something like that, and you wanted to just share it as a library, like other people can call that and just like pass in some values, and it'll give you the part back. And yeah, most of these tools as well can be compiled to WebAssembly and like hosted in a website of some sort, so you can easily share your models. Drawbacks, of course, are it's going to take you longer to make something just with code, because it's kind of a weird, like making something like it's very visual, like you know what the part looks like and you want to just click around and make that. So doing it in code is definitely more of a mind bender, and it can be hard to visualize. So it's important to have some sort of like immediate visual feedback on what you're doing. The other hard part is like selecting the edges or faces or features that you want to modify in some way. So if you like, I know like I can just click on this edge and chamfer it in this other tool, but like how do I get that particular one in code? It can be more challenging for sure. And same with sketches. It's sort of like writing an SVG by hand. It's not super fun. And you look at it and you just like, I don't know what the shape is. I just need to like draw it out or like go through each point in your head and see what the shape actually is. So it sort of becomes like write-only code. So I'm thinking maybe code-based CAD just on its own is not the ideal tool. There's almost certainly not. There's probably some sort of hybrid between the two that would be nice to have. So like having a UI for creating sketches and selections would be good, especially if it generated code that you could then use. And of course, yeah, again, having a viewer app which hot reloads your code and just like gives you those quick iteration cycles is important. There's a paper for another tool called CAD Query, which also has like sort of a query language DSL for selecting things. And these people made like an interface where like the code generates a shape, and then you click on a particular edge or a face, and then it comes up with the query that you would have written in code to select that particular face. And it tries to be as robust as possible to changes if you make other changes to the geometry. So that one could solve the selection issue. And then, do we have time for a demo? Okay. One thought with Rust is like the compile times take quite a while. But if you have ever compiled something in like a no standard environment or with WebAssembly, that's actually quite quick, especially in debug mode. So I wanted to show, I have like a cargo watch script running. So anytime I make changes to this model file, it'll compile the code to WebAssembly. And I have this viewer app which will just display, read in, it'll detect when the WebAssembly file changes, and it'll read it in and execute it as model code. Hopefully. And then I gotta adjust this. Sorry, I'm not on my laptop that I normally use. So anyway, so here's a part. This is the rounded chamfer kind of part from before. And we have the code for it. I know this is super, super clumsy. Yeah, so here's the code for it. And it's just the same thing that I went through before. But as you go through and change it, hopefully it'll update. So let's say I was extruding it by 3 units, and maybe I want to make it a bit taller. Hopefully when I save it, it'll get taller in the viewer. And yeah, there it goes. So yeah, it's like the least exciting demo ever, but because scripting languages just do that. But it's going through a lot of layers to get to that point. So again, like there's this whole WebAssembly API that I created, and this is all experimental, so like not everything is implemented yet. But it's a WebAssembly API. You write code against that. It's very lean and quick to compile against, and the viewer side of it has a WebAssembly execution engine, and it's like calling host functions and OpenSCAD. There's like so many layers to it. I'm still not completely convinced that this is the right way to do things, but I have the beginnings of something like interactive without having to use dynamic linking. I can go into more details on that if you want, but the gist of it is you get into all of these things with WebAssembly, with lots of acronyms. And one of them is WIT, which is like WebAssembly interface types, I believe. It has this whole language that you can define and create. And then you essentially have like the guest side of things, so it's like someone writing model code, and then the host side of things, which is like the viewer application actually executing the guest code. So you create this WIT file that sort of both sides sort of agree on, and you can use different things, but for the most part, I think WIT bindgen is the tool to use, which will generate Rust bindings for you to call the host functions, like different geometric operations that you want to do, for example, in this case. And on the host side, like the viewer application, I'm using WASM time, and it also has a similar like bindgen kind of thing. It'll spit out these traits that you then have to implement, and those are sort of like the host functions that the guest calls. So I did that for a few of OpenCascade's functionality. Like I didn't do it for everything yet because I haven't, again, come up with an automated way to do this. But the end result, though, is if you add a few macros in, you end up with essentially a crate that you just pull in like normal in cargo.toml, and it exposes a trait that you have to implement, so just model. So you can have whatever struct you want. Maybe you can hold some data or whatever you're doing. And it just needs to implement the model trait. So you need to have some way to construct it. And then for now, it's just like a function that says create model, and it just returns a shape. So you just put in whatever shape you want to make in here. And the only thing you have to do is call this macro here, model API register model. And that'll connect all the machinery and everything together to get this working. So from the user's perspective, it's quite easy. You just add a line in cargo.toml and then implement a trait, call a macro, and then you can get these models hot reloading. This is following the Z extension API. I'm just gonna hide this. So that's where I first saw something like Rust doing this, because for the most part, people either add in a scripting language of some sort, or like they use dynamic linking. And I saw that. So Z is a text. How many people have heard of Z or use Z? Yeah, like most of us. So it's a text editor written in Rust, and you can write extensions for it in Rust, which is kind of interesting. And they get distributed as WebAssembly. So I kind of looked into how they were doing that, and basically copied their their architecture. So take a look at the Z extension API for implementation details on how that's done. It's pretty interesting. There's a bunch of other stuff that I want to add to this crate. It's nowhere near finished. If you make a part, you probably also want to attach it to some other part. So that's like assembly. And I want to come up with a nice ergonomic way to do that in Rust as well. It'd be nice to be able to model constraints between these things. So you can say these two things are parallel, or this one needs to be this distance from this thing. I work with KiCad to create PCBs, and it'd be nice to be able to just import the PCB and have it automatically generate some geometry that sort of fits the PCB itself. Sheet metal bending I threw in because that'd be cool to have as well. You can make things for pretty cheap with that, but you need a tool to be able to model how that all fits together. Yeah, and some other nice like render, document design, drawing kind of things that just get rendered automatically. So going back to solve space as well, like there's, it has a constraint solver, and someone wrote bindings to that for Rust. So that's potentially something that I could use. Again, it's great that crates.io exists, so I can just go grab this library and try it out and maybe integrate it into my project. There's a ton of other code-based CAD tools out there as well. So I'm not going to advocate for mine because it's also not done. But if you like writing Python or you like writing JavaScript or some of these other languages, there's tons of different tools out there to try out. So definitely give one of them a try, at least. One person even made their own language and built it on top of my bindings, which was kind of cool. So he ended up contributing quite a lot to that. And he created his own sort of declarative syntax and language. And he has a web app and everything. It's called DieselCAD. If I were starting today on this, I might have picked RepliCAD. It has sort of a similar imperative API to what I've created so far. Although mine is also very inspired by CAD query. But yeah, RepliCAD's very nice. I would check that one out first just to get an idea of like what a complete product would look like, and then imagine maybe the Rust version sometime later when I finish it. And going back to CAD kernels, there are two that I know of being developed right now, and they're just not ready yet, so it's not something that I can add in today, but they're in development. One is called Truck, and I believe the team is in Japan. So they're going through and implementing that. And Fornyacht is the other one that I know of. Mostly one guy just cranking through it. I've looked at his repository, and it's like 18,000 commits in there. So they're both building boundary representation CAD kernels like from the ground up in pure Rust. So those projects should definitely get some love as well, and hopefully one day I can swap out the CAD kernel that I have in my project, and it'll be just pure Rust, and everyone will be happy. The other interesting side effect with code-based CAD is you can ask ChatGPT to make crappy models for you with it, because ChatGPT can write code. You can't really ask it to like click around like SolidWorks or Blender or something and make a model for you. So this is the next best thing. Maybe someday it'll get better and we'll be able to just ask the computer to make a part for us. I don't know. Do we have time to like? Okay. So if you want to make something either with a GUI tool or with code-based CAD, just buy digital calipers. They're great. You can use them, like if you have some part or whatever, you want to model something that fits with something that already exists, just buy those. They can be digital, they can be analog, whatever. But it just gives you accurate measurements of the parts you want to fit. And it's huge quality of life improvement. And then I made two versions of my case, keyboard case, which I'll show in a second. One of them was printed on a printer from 2014, and one was printed on a printer from 2023. And the difference between the two is incredible. And I wanted to show like two videos just sort of comparing them. Let's see if it'll play audio. This is the one from...
printer continues to stack up layers of the plastic material until done. When finished, the print pad moves all the way down and your object is removed by placing the print pad and the object in water. So that's it for our quick overview of using the cube.
Yeah, so it's just like this horrible print job by 2024 standards, and you have to dunk it in water to remove it and all that. It's just kind of clumsy. Let's see what printers from today can do.
So yeah, let's see it print.
Oh no. I pressed F12. What? I kind of ruined the joke, but
All
yeah.
the pieces are
Hopefully you saw that.
They came out pretty well.
Sorry, I opened the developer console and I couldn't close it, but the difference between the two is amazing. So I printed here, I'll show these now, I guess. This was the first version of the case. This was with my OpenSCAD bindings, but like the first iteration of it. And it was on a printer from 2014, and it takes a lot of tries to get it to succeed. I eventually got one that wasn't too warped. So like last year, one of my coworkers just like bought a Prusa MK4 kit, and he just like left it in the office with a sign that said, "Please build me." And I was like, "Oh, that sounds kind of fun, actually, like building a 3D printer." It took like 18 hours over like 3 days to assemble. It was excruciating, but when I finished and like started it up and printed, it was flawless. Like it completely worked. It was the most beautiful thing. And it's just so fast compared to the one from 2014. So that inspired me to actually like buy my own MK4. You won't be able to see this like in much detail from where you're sitting. But this is like the version 2 of it that I printed. So this is on the Prusa. Just come up and see it afterwards. Yeah, you can pass it around. Yeah, the feet might fall off because I haven't attached those. But anyway, yeah, you can pass this one around too if you want. So this is the first version. And yeah, when I realized I had to give this talk in like less than a week, I had to crank out the version 2 of that and get it printed and actually working. So let me show some pictures of that. Also, yeah, I'm not going to show these, but there's such a thing as CAD speed modeling tournaments. And if you haven't watched those, you should definitely check them out. They'll give them like a design drawing, like 3 orthographic views of it, and then like, what is the mass of this part in grams, down to 2 decimal points or something. And then they just have 2 people like on Twitch, and they're just like live streaming their CAD software and just like drawing as fast as they can, and extruding and subtracting, and then like they just type the mass into the Twitch chat, and whoever gets that first wins. It's incredible. I had never heard of that before until I put this talk together. So yeah, anyway, my repository is at bschwind/OpenCascade RS. Go buy some digital calipers, buy a 3D printer, and go make some cool stuff. So yeah, the finished product is making its way around. Here's some pictures of it as well. So this is just like already in the case. You just need to put the switches in and the keycaps. Again, that's the PCB and the top plate, and they're just gonna, I designed it so you can just like slot it into the 3D printed case. So that's the end result. It has nice rounded edges and chamfers, which is very easy to add. It's got a nice little USB-C port cut out. I was kind of happy with that. And then it has these feet so that, because I wanted to put it on my keyboard, but I didn't want it to press any keys. So these feet like fit in between the grooves of the keycaps, so it can stand on it without pressing anything. I was pretty happy with that, and it actually works. I was super happy with it. It took like 6 iterations to print it and get it right, but yeah, now we're there, and that's pretty much it.
Well, I feel like I'm no stranger to OpenCascade, but it was definitely a lot. So I'm just guessing people are going to have questions. If you have a question, please raise your hand. I'll bring you the mics.
So when I do CAD than more traditional GUI software. And if I go back and modify some feature, and then it sometimes fails to rebuild correctly, and I have to go and fix up everything manually. Do you have this kind of issues in code-based CAD? I don't know how you select the features that you want to modify, but what's that?
Right. You do run into that issue in the same way, where like if you go back and just radically change some parameter about it, it will, like in some case, like if you make something like too small, but you were trying to fill it that whatever edge, and that now extends over the bounds of that part, you're going to run into the same issue. So I don't think there's like just an automatic way to solve that problem. It's sort of like you're asking it to do something impossible. But usually, if you roughly know like the parameters that you want to pass to your model, and you go like line by line as you're building it up, you can usually figure out which line like caused the problem, because it's like, oh, the one that I just added, essentially. So you have the undo buffer, and it can make it a lot easier to figure out where things are going wrong.
I don't know if Rust helps you find those issues. You mentioned that it may be crashing at the moment, but
yeah, not so much. Like there's not much, like in this case, there's not much that you would want to do except just crash and like print an error of some sort if you asked it to do something that it just can't do. So Rust doesn't really help you too much with it, but you can at least dig in a little bit and add result types, and at least explain like, oh, you passed a fillet radius that's too large or too small or something like that. Yeah, right now, that's the ideal. And right now what it is like, oh, I just added this line that fillets an edge, and it seg faulted. So it must have been the fillet radius, I guess.
Okay, thank you.
Brian, is the query for like finding the furthest point, is that part of OpenCascade, or was that your own kind of riff on that problem space?
It's my own riff on it so far, and it's just like it's the most naive like linear find kind of thing right now. So it just goes through it iterates through every edge or face and like tests it for this.
That's smart. I love that. That's what I always want, is because I'm like, okay, extend this to this face, or the sort of minimum face.
Yeah.
Does it work? Have you adapted it so you have like max X or max Y? If you have different work planes, can you?
Yeah, I want to extend it later. It's got the most basic stuff right now, just like the X, Y, Z axes, like farthest point in this direction or that one.
Yeah, that would be cool to be able to say, like, I have a work plane, and then find me the furthest point of the part from that 45-degree plane or whatever.
Yeah, OpenCascade does have some like ray testing stuff, and I think I've exposed a little bit of that.
Cool.
Just to be able to give me the next face like from this point. That this ray hits, so that I can then start building on that. That functionality is in OpenCascade, and I think I actually have bindings to that because I wanted that. OpenCascade has a lot of functionality to add in, including being smarter than doing a linear search. So I just need to expose those bindings to Rust, essentially, either manually or automatically in some way. And then we'll be able to use that.
That was the other thing. This is more of a comment than a question, but don't sleep on TreeSitter for actually, so you don't have to write a C++ lexer, because the output from TreeSitter is structured, and you can, it has the types and everything, essentially, which might be enough for you to generate.
Absolutely, thank you.
So I've been doing some FreeCAD recently, and one of the biggest issues I've had trying to get 3D printed stuff is that, like when I export stuff, I get non-manifold stuff for random reasons, and sometimes it can print, sometimes it can't. And one of the issues is that OpenCascade apparently has issues with certain Boolean operations with tangents. Have you encountered many of those issues or found ways around it?
I haven't yet been able to get this to generate non-manifold geometry, and you're probably, since you're using a GUI, probably making something a bit more complicated than what
I promise I've been using simple stuff, but it's still, like I just Boolean like a cylinder with like a cube, and it goes like, sorry, non-manifold shit. You go, did I put it 2 degrees off or something strange?
If you want to come over later, like we can try to model the same thing in this library and see if it works or not. I've definitely, like, OpenCascade is not super stable, and there's a lot of times where it just gives up or doesn't do the thing you want it to do. but it's like the best we've got right now. So we have to deal with it. But yeah, I'd be interested to see, because I've never been able to like model anything in FreeCAD yet because I rage quit it. But if you could show me like the part that you're trying to make or something, just something that crashes it, I want to see if I can replicate that in this. That'd be interesting to try.
How many lines of code did it take to build your keyboard?
Oh, good question. Not too many. I think it's like 200. I mean, it's like, depends on what your definition of too many is, but 400 lines of code. Yeah, kind of a lot. But if you read through it, it's not too bad overall. Like the main functions, sorry, I'm like craning my neck to just like look at this screen. So it starts here, and you sort of just, you know, for each main component of it, you just extract it into its own function, and then you do Boolean operations on those for the most part. So like I have like an outer box and an inner box. You subtract the inner box from the outer box, and you kind of just go, it's procedural in a way. And like, as an example, I have these like support posts on the side that you can screw the PCB into. And you can just like make a struct for support posts, and you can throw those into an array and then just like loop through them and just union them all together, and suddenly they're all added onto your model. Or like, there's different locations on the bottom of it where I needed like a hole so I could like press the reset button, or like there's something else there. Like screws are going through it in some way. And so you can just say like case equals case dot drill hole at all of these locations that you've defined. So it looks like a lot of code, but if you organize it well, it's no more intimidating than any other piece of software.
Thank you.
Good question. Yeah, sorry, that's a long explanation.
Thanks. The first iteration of the keyboard you made sounded great. And I was wondering if you specifically tried to optimize for the thumb, or is that just a natural property of the filament you're using?
For that first version of it, I was. So I like put some foam in the bottom of it. Yeah, the typical, the usual suspects for getting that nice sound out of it. The second iteration, I literally put together like a few days before I flew out here. So that was a rush job. But I also wanted that one to be like the keyboard I use around other people so they don't hate me. So I put silent switches in. Yeah, it's very, very quiet. So
would it help for the thumb if you use like a really dense filament?
Probably, yeah. Like actually, I was originally trying to print with PETG, but I was still iterating on like the tolerances and everything, and I only had like one spool, so I didn't want to waste it. But that one's like slightly denser and has a slightly nicer sound than PLA. So both of those are made of PLA. Ideally, the final version I'll make is PETG or some other material.
Would it help as well if you had one solid piece as opposed to two separate pieces you joined together?
Exactly, yeah, definitely. It's a little hard to print the feet though. I tried to do that as one part. I like flipped it upside down and added supports on the inside, and it came out super, super ugly.
It came out awesome, man. You should be proud of yourself.
Well, no, this one was not using supports, but like the ones that I didn't bring, they did turn out quite ugly. I can assure you.
I got a second question as well. I realize you might have covered this in the last talk you made, but the firmware, did you write a wrapper for QMK? Did you use QMK?
No, it's pure Rust.
All the way through?
All the way through.
Awesome.
Yeah, it's open source as well.
Yeah.
A brief overview is it's using the RP2040 microcontroller, the Raspberry Pi Pico kind of thing. And yeah, like people have written these abstractions over these microcontrollers to be able to talk directly to peripherals and everything like that. And so there's some crates that I'm using to be able to do that lower level stuff without having to write unsafe code for the most part. But it is in all Rust. There's no QMK code involved with it.
Is that on your GitHub as well?
Yep.
All right, cool. I'll have a look. Thanks.
It's called Key Ripper.
Thank you.
No. All right, that's it then.
Thank you, everyone.
Brian. Since this is not your first time, I'm not gonna do my whole interrogation spiel. Just one question: what's a topic you would like to see next?
Yeah, maybe a deep dive. Maybe a deep dive again into like what's the best way to create a plugin system or something with Rust, or just like solving that compile time issue, because it is a problem. And I'm going the WebAssembly route and trying it out. I'm not quite sure yet if that's the way to do it or not, or if there's better things on the horizon. But that would be interesting. And also, we always mention game development as something that'd be cool too. If someone made a small game and wanted to like show off like what tech they use for that, yeah, that'd be interesting.
Great suggestions. Thank you. I hope you all are taking notes.
Thanks, everyone.